Okay, we're going to do our next type of technique for integration by using partial fractions. So if you have not done partial fractions before, then you're going to need to go through and figure out this technique. But most of you have done partial fractions before. For some of you, it's been a couple years. For some of you, it's more recent than that. So I'm going to go through and I will do a problem that does do partial fractions as well, so you can kind of see what it looks like. So just talking about rational functions, how they can be a little challenging to integrate. So our example, we just have one example today. So I'll show you how to do partial fractions on here. So a problem like this, they can be a little challenging. I mean, the first thing I would try to do here is long division, but you can't because the bottom has a higher power than the top, so you can't break it down like that. So you're going to have to write this out as separate fractions. So here are the techniques here. Okay. So since the step one's kind of done for us already, because again, I said you'd want to use long division so that the bottom power, if the top power is higher, but this case, the bottom power is higher, so really can't break it down anymore. And then you want to factor everything, and we'll do that in just a second. And then here are really our cases for BC. So if you have linear factors are repeated, so you would just write this as into A over whatever plus B over whatever. However many factors you have, that will dictate what your A, B, and C are. If you have repeating factors, you're going to have an extra one. So if you just have two different factors, then you're just going to have two of these. If you have one repeating factor, it will also be two of them because it's repeating. If you have quadratic factors, just be careful. So that would be, if you have a squared factor on the bottom, you would just do ax plus b on top, and so on and so forth. So let's just go ahead and tackle this problem. So really, before I do any calculus, I'm going to want to rewrite this because all of our techniques up to this point are not going to work. So I want to rewrite this as a fraction. So the first thing I'm going to do is I'm really just going to do a little bit of side work here. So I'm going to do 5x squared minus 3x plus 2 over x cubed minus 2x squared. Okay, and I want to factor the top and the bottom here. Actually, no, sorry, just the bottom. The tops do not factor the top. I'm going to have issues with that. So let's factor the bottom. So to factor the bottom, and the top doesn't factor anyway, I can take out an x squared, and I'm left with an x minus 2. Just double checking everything. That way I don't look at my notes the entire time. Okay, got it. And then the top is going to stay the same. Now this is going to equal a over, since I have a repeating factor, I'm going to go with just the single factor, plus b, the repeating factor, plus c, which is going to be my x minus 2. Okay. So with that being said, I need to figure this out right here. So for partial fractions, I'm going to multiply everything here in blue by x squared x minus 2. So I multiply all of that through. On the left side, I'm left with just 5x squared minus 3x plus 2 equals a, and then one x cancels out, so I got x minus 2 plus b, x squareds cancel out, so x minus 2 plus c, and you just have the x squared. Okay, there's a couple different techniques. I'll do the one that's the most common technique and just rewrite this as systems of equations as I go through here. So I'm going to rewrite this. So this is going to be a x squared minus 2x plus, and then nothing else changes here. And now I'm going to distribute everything so that I have ax squared plus, or sorry, that's not a plus, minus 2ax plus bx minus 2b plus cx squared. I'm now going to organize this so all of my x squareds are in front, then my x's, and then just my constant. So for my x squareds, just have these two guys. So I have ax squared plus cx squared. For my x's, I just got those two. So I'm going to get negative 2ax plus bx. And then my constant is actually just going to be this guy right here, minus 2b. And this is all equal to 5x squared minus 3x plus 2. So what's going to happen here is I'm going to actually factor one more time in a factoring here of an x squared out. So x squared a plus c plus factor out an x. And the reason I do that is because I'm going to be left with a negative 2a plus b. Okay. And then minus, there's nothing factoring right there, 2b. So the reason I do that is because this a plus c has to equal this x squared value. So a plus c must equal 5. Negative 2a plus b. Oh boy, I'm struggling on writing this down. Negative 2a plus b has to equal negative 3. Okay? And this negative 2b has to equal 2. And usually it'll be set up in a way where you could just use substitution. So in this case, we have a slam dunk here. Well, this is going to tell us that b is indeed equal to negative 1. So now take that and plug it into any of my other b's, which is going to be this equation right here, which is going to be negative 2a minus 1 equals negative 3. Okay? And then solve for a for here. And add the 1 and divide over. And this is going to tell us that a is equal to 1. Not bad. Since a is equal to 1, let's come up here, and this is going to turn into 1 plus c equals 5, which is going to tell me that c is equal to 4. So now I'm going to plug these values up into here and rewrite this. So here I go. I'm going to go ahead and do that in my integral here. So this is going to become a over x, which is just 1 over x. This is going to become plus b, which is going to be negative 1. So how about just minus 1 over x squared? It's not bad. And then plus c would be plus 4 over x minus 2. And this is all dx. Now, if this was a fraction, I know that in pre-calculus you were learning that if this is a fraction, you would want to put the fraction part on the bottom. Like if this was 1 over 2, you would put 1 and then 2 on the bottom. We're not going to do that because that would just be a coefficient for us. So we'll just leave it. So let's go ahead and integrate all of these parts. So integral of 1 over x, that's a formula. That's just ln of x. Okay, integrating 1 over x squared. That's not an ln of x. This is actually an x to the negative 2. So this is where we're going to add 1 and then divide. So we're just going to be left with a 1 over, so minus negative 1, I don't want to go too fast, x to the negative 1, plus, keep the 4, and then that's just like a baby u sub. Since the derivative is just going to be 1, it's just going to be ln of x minus 2 plus c. Okay, and then actually this needs to be absolute value right there, and so does this, because those values could be negative. So let's rewrite this, make it look a little bit prettier. And I'll do my final answer here in my maroon. So we're going to get ln of x. This turns into a plus 1 over x plus 4 ln of x minus 2 plus c. All right. One helpful trick I have seen before, and I just want to talk about it so briefly, is people will actually integrate this part right here. They'll go through and integrate it with a, b, and c, and then plug in later. So let me just show you that real quick. If I were to integrate this, a, b, c, so some people do this. They'll do this first. So you're going to get a ln of x plus, this would be b over x, or sorry, it'd be plus negative b over x because of that integration, plus c ln of x minus 2. So they would do this, and then they do all this work. So they would do the calculus first for the most part. And then I would just go, oh, okay, then just plug these numbers in. And the reason people do that is because just in case these happen to be fractions, that really helps deviate from making any errors with these fractions. So we can always do it that way if you prefer. So there you go. There is our video on partial fractions. If you do need extra practice on partial fractions, definitely Google it up and we'll get different strategies for you. So this is supposed to be just a quick reminder how to do it. If this is totally new for you, then you're definitely going to need to Google it up to brush up on some of your algebra techniques so that you can do your partial fractions. And that is it.